All right, so we're back for the last part of this node section, and that's principle of reduced triangles. Basically, this is when you have, you're going to lean on similar triangles, and you're going to factor out some shared divisor of each of the sides you have, find the missing side, and then scale it back up. This is best seen through an example, so we'll go down here to one of these that aren't worked through yet. All right, so if I look at this example here, I've got 36 and 39. Both of those are divisible by 3. So this first one I've got 3 times 12. And then over here I've got 3 times 13. Now, when I've got a 12 and a 13, if I scroll back up to my triples, we know we have a 5, 12, 13. All right, so we're going to use this principle of reduced triangles along with the 5, 12, 13 relationship to say, hey, 12 and 13, we know this last side's 5, but the whole thing's scaled up by 3. So we can get 3 times 5, or 15. All right. If I look at the next one, both of these are divisible by 7. So I have 7 times 7 and 5 times 7. So these two sides are 5, 7. And I want to find the last one. So what I'm going to do is I'm going to temporarily ignore the 7. And I'm going to look at 7 squared plus 5 squared equals our pre-scaled up b value, so b squared. 7 squared is 49. 5 squared is 25. 49 plus 25 is a 74. All right, and then we take the square root of both sides. And if we reduce that, we'll go off to the side. 74 is divisible by 2. 37 goes in there, and then you're stuck. All right, so that's simplified. We have root 74. Now, that was the b side before we scaled it up by the factor of 7. So we're going to scale it up by the factor of 7. And we're going to get 7 times root 74. All right, and that's going to be our missing side there. Now, if I go to the last one here, we're going to use the same idea. Here we have 48, which is divisible by 16. And we have 64, which is also divisible by 16. So if I take 48 divided by 16, I get 3. So I've got 16 times 3. And then if I take 64 and divide it by 16, I get 4. So 16 times 4. So you notice we've got a 3, 4. So that means this last side using the 3, 4, 5 family would be a 5. But the whole thing is scaled up by 16, so we're going to scale this by 16 as well. And we get that C equals 16 times 5, which is 50 plus 30, or 80. All right. So again, we're just looking at kind of taking out that common factor, finding the missing side, whether it's by a triple or Pythagorean theorem, and then scaling it back up. All right, so that takes us through 8-2A. Bring your questions to class tomorrow.